Hello and welcome to today's video. Today we're going to be taking a look at the OLED display and how to get started with it. Okay, so if we start looking at the OLED display. So pretty much here I've just included the two libraries, the SSD 1306 and the GFX library, which need to go together. When you install the library for the Adafruit, it will also offer to include the GFX library. Now most of this code is just copied from their example, but fundamentally all we're doing here is we're setting the screen diameter, so the width, the height, the OLED reset, and the key thing for the I2C is the screen address. Now, in the datasheet it says 3D for the 128 by 64, but for whatever reason my board is coming up as 3C. Now, the key thing is, if you're ever unsure on what the I2C address is to go into the file under examples, wire, I2C scanner. Extremely useful example sketch. Upload it. You're uploaded, and then if we look at the serial port monitor, we're going to see the devices that are found. Now let me just disconnect mine for a second. Okay, so you can see in the serial port monitor it found 4 devices. Now I know the 50 and 57 are my memory, and I know 68 is my real-time clock. So that means my only thing left is my display, and it's coming up as 3C. So therefore 3C must be used for the address to my display. So here we have it. So I set the screen address to 3C. Now to initialize the display, it's just a single line where we create a display object with the appropriate width and height, the reset command, and a pointer to this wire. Now this is an underlying class, which is a 2-wire interface, which basically is the I2C interface. I've got a few little definitions for switches which we're going to be using. Actually, we're not going to be using those, not for this demonstration, so we can get rid of those. In fact, we're not even going to use the LED. So let's just simplify it down. Okay, so here we have it. We just have code purely for the display. Okay, so I initialize my serial port monitor to whatever speed I'm going to be using. Then with the display, the key things are the begin statement, which basically checks and starts the communication off with the OLED display. Here again, the key thing is we're passing in the screen address. Then finally we're clearing the display, which is basically resetting the display's memory, and the display method basically says to put whatever's in the memory on the screen. So fundamentally all this is going to do initially is power up and reset anything on the display. So let me just, for laughs and giggles, if we don't clear the display, I believe the display actually has a self-test screen. Oh, making sure to plug in the module. Okay, so that is where the failure occurs. If you try to upload a sketch without this connection to the Nano, Windows throws a fit and doesn't then allow you to use the port again until you power cycle the computer. I've come across this a number of times. I wasn't exactly sure what triggered it, but that looks like that's what triggers it. Is if I try to upload a sketch with the Arduino Nano not connected, it crashes my Windows USB port driver and I have to power cycle my PC. So please bear with me whilst I power cycle my Windows PC. Okay, so I'm back now after resetting everything. Don't you just love Windows? Anyway, where were we? So basically we just got this connection going and I've hooked up the device, and this should basically just display whatever's in the display memory when it's power cycled. So uploading the sketch, and there we go, and there we see an Adafruit little logo. Fantastic. Now we see two colors. We see yellow at the top and blue at the bottom. Now this display is not multicolored. It basically is just one color LED, but the top section is tinted as well as the bottom section. The top section is tinted yellow and the bottom section is tinted blue. This just gives the impression of color, but we're actually just doing white pixels. So first step is if we don't want to see the display, let's just clear the display before using it. So if we just send a clear command before the display, clear should remove anything from the memory. And there we go. So it's uploaded. We've cleared the display and we've displayed the empty memory. Now this display is, well, I shouldn't say this display. The Adafruit libraries make it fantastically simple to perform very simple or very complex tasks with almost no programming knowledge. So we've already seen clear display and begin. But now basic ones are, we've got draw lines, get buffer, get pixel buffer. Some of these are a bit more complicated. We've got scrolling text from diagonal left, diagonal right, left, right, starting scrolling, stopping scrolling. Right, but we have things like draw bitmap, draw character, draw circle, circle helper, draw grayscale bitmap, draw line, draw rectangle, draw RGB. Again, these libraries are designed potentially for other displays, so obviously this is only a monochrome display, so an RGB bitmap probably won't do much. Draw a rectangle with rounded edges, draw triangle, draw things which fill with color. So let's just draw a rounded rectangle X. So if we start maybe at down 20, width maybe 40, width 40, radius 4, and let's give it a color. What is it? Oh, sorry, 1306 underscore white. This is just a predefined color, but basically it just equates to, I believe, 1. So white basically is turning the pixel on, and black will be turning the pixel off. So now what we have is we just clear the display, drawing the rectangle, and then we're displaying it. And uploading the sketch, and there we can see on the LED display we see a rectangle 40 pixels wide with corner radiuses of 4 with a 20 pixel offset to the right from the top left corner and 20 pixels down. You can see how to draw a shape, but we can also do things like display right. The typical hello world statement, but there's a few other commands which we need to use as well. There's one called set cursor, which basically sets the starting point for the text. We can also display dot set text color. The 1306 underscore white. If I can type white and display dot set text size. So let's see what this does. So we still got the rectangle, but we're now trying to write text size, and there we go. When we look at the screen, if we zoom in a little bit, we can see that we've got hello world and with D on the following line. So with this display, again, if you set cursor, it will write the characters in sequence starting from left to right, but if it goes outside the bounds of the screen, then it will wrap over. So if we decrease the size of the text, it should now be written on a single line. Uploading, and there we go. So the text size is smaller, and it is then displayed. I'm not sure whether it's an integer, so we can't change that. Now, what we can do is just, if we wanted the text to be in the main area of the code, just by playing with the cursor location. So remember X, Y. So if we come down 30, what we can do is, so let's make this larger, hello, but shorten it down to the world. $60. Okay. So now we've got rid of the rectangle, and we're just playing around with the text size. Oh, there we go. Hello. Oh, too low. I'm not sure what the board will be. 20, 40. Okay, yeah, we're 64. The screen is 64 pixels high. There we go. Now we've got hello world. So just by playing with the cursor location, the text size, and what we want to display, we can now, again, just to be clear, once we set text size, the that parameter will stay set until it gets reinitialized. So again, the key thing with this is we can then play around with the various sizes and characters and fonts to get it to display exactly what you want. There we go. So we've got demo, hello world. So that's pretty much the basics of getting started with the display. So here's an example of one I played with a little while ago, just as a little demo, just to see what we can do. So in this situation, I just created a dice rolling utility. So when we press a button, we can get multiple dice displayed and a random roll. With this code that I've got, I can actually programmatically change like how many dice and how I want to display them, whether I want to display them as a line image. So let's just do a 2 dice. So we can just do a randomized dice just for a bit of fun. But I can scale the dice image. Oh, double 6s. I'll win a prize. Now, if you're interested in this code, I will be putting together a few videos to walk you through actually how I created the code and how it works. But otherwise, just have fun playing with the I2C interface. And if we start with the display, I will be going on and playing with the EEPROM, the real-time clock, and a few other sensor modules. Hope you've enjoyed the video. Thank you for watching.